Today we're diving into the fascinating world of stress and its ripple effects on our brain and body. Think of it as a wild roller coaster ride through your internal landscape. So buckle up and let's explore how stress can turn from a helpful alarm into a bit of a troublemaker. First off, stress isn't just feeling overwhelmed when you have a mountain of work or a looming deadline. It's actually a complex biological response involving your nervous and endocrine systems working together. Central to this is a tiny but mighty part of your brain called the hypothalamus, which acts like the boss of the stress response. When danger or stress hits, the hypothalamus signals the pituitary gland, often called the master gland, to release a hormone called corticotrophin releasing hormone, or CRH. CRH then prompts your adrenal glands, those tiny glands perched atop your kidneys, to produce cortisol, often dubbed the stress hormone. Cortisol helps you deal with stress in the short term by increasing energy, suppressing non-essential functions, and preparing you to fight or flee. But if stress becomes chronic, this system can go haywire. Persistently high cortisol levels can impair your hippocampus, the brain region involved in memory and emotional regulation, reducing its plasticity, which is its ability to adapt and change. Imagine your hippocampus as a sponge that soaks up new information. Chronic stress can make this sponge toxic, leading to neurotoxicity, and even cause the brain's protective barriers, the blood-brain barrier, to become more permeable. That's like opening the gates to unwanted guests, including inflammatory molecules like cytokines, which are tiny proteins that help coordinate immune responses. Inflammation isn't always a bad guy, it's essential for healing, but when it lingers from chronic inflammatory disease or prolonged stress, it can cause problems. These pro-inflammatory cytokines can cross the blood-brain barrier, influencing brain chemistry and mood. They can activate microglia, the brain's resident immune cells, and astrocytes, which are like the brain support staff. When microglia go into overdrive, they release substances that can damage neurons, especially via molecules like quinolinic acid, a product of the Kynurenine pathway. The Kynurenine pathway is a metabolic route that kicks into gear during inflammation. When activated, it shunts tryptophan, the amino acid your body uses to make serotonin, away from serotonin production and toward kynurenine and its metabolites. This shift can lead to a decrease in serotonin, the neurotransmitter, often called the feel-good chemical, which influences mood, sleep, and appetite. Lower serotonin levels are linked to depression, especially major depressive disorder, and feelings like anhedonia, the inability to enjoy things, and fatigue. It's not just serotonin taking a hit. The same pathway produces neurotoxic compounds like quinolinic acid, which overstimulate NMDA receptors for glutamate, another key neurotransmitter. So in the end, these processes alter neurotransmitter levels. Inflammation and oxidative stress can lead to cognitive and emotional symptoms we associate with depression and anxiety. Next time you're feeling stressed, remember your body is doing an incredible dance of chemistry and communication. Thanks for joining me on the whirlwind tour of stress in the brain.